Let's look at logistic, how we use logistic regression in our given problem. So, our problem is classified between two outcomes. That is, either it's a hydron event or it's a gamma particle. So, identifying between these two particles is the objective. So, it falls under the binary classification. It's either between it's just two classes. So, logistic regression best fits within uh, within our within our problem that we have. Then let's look at logistic regression. So anything, it starts with linear relationship. Any can be a logistic regression starts with fitting a linear model into the data. So that as we can represent the output as z is equal to w1 x1 plus w2 x2 plus the bias. So where w represents the weights and x represents the input parameters. So let's look at it as a sigmoid function. So it can be represented as sigma raised to z is equal to 1 divided by 1 plus e raised to minus z, where the output is lies false as a probability that lies between 0 and 1. And we put a threshold that here it's zero point 0.5. So anything beyond more than zero point 0.5, we classify it as one group, and if it's less than that, we classify it into another. How do you train a logistic regression model? So you use a log loss function, also known as constant syndrome. It's basically you you uh, you go through all the training samples and trying to find optimal weights, uh, W1, W2 till n, and which gives the best prediction. And we use an optimization technique called as routine descent to arrive at optimal weights much faster. There are key assumptions that we made when using logistic regression. That is, it is linear and independent of features, and the outcome is going to be binary. That's either one or no. Let's look at pros and cons of logistic. It's very simple, interoperable. The problem we can also do property predictions, and it's very efficient. This cons would be it assumes linearity and not suitable for complex problems and sensitive to outliers. Let's look at the output based on the code. From scikit-learn, we import the model, logistic model. We train it, train the model based on our training data set. We predict it for the given test set, and we compare it against the actual data versus prediction, and we can see the outcome. So let's look at the precision. Precision is representation of the positive predictions to that which was actually correct. Recall represents the actual positive values that was correctly identified. F1 score is a harmonic mean between both of them, and which gives a good picture between precision and re- trying to identify the right balance. Support is basically the actual number of data points in each classes. Here, if you look, uh, we have a overall if accuracy of 7.8, close to 80%, which is uh, which which falls under as a right candidate for a good classifier for the given problem.